Hi, welcome back. It's been a while since we had an update on video for the electronic referee. I've been busy trying different code and things like that and trying to get to grips with the various pieces of hardware that I need to make this all work. Still have some issues with it, but I do have a proof of concept working using Energia code so other people can have a look and see what I'm using. I think I may have to go on and convert everything into Code Composer Studio because the libraries I think are better supported there, but I'm going to have to find a combination that works with the sub-gigahertz radios, the LCD displays, as well as the different boards like the 2553 Launchpad and the MSP 430F 5969. There's various combinations and each one has its own little quirks. And some won't work with the battery booster packs, which I discovered they become a little bit unstable, and some do. So it's been a little bit of a challenge to find a combination that's actually going to work, and I pretty much have it working now, with the exception that the radio software under Energia, the library, is a little bit flaky to say the least, and so is the display for the Sharp 96 displays. They work, but they have limitations, and the radio especially, when it starts receiving from multiple sources, it can start overwrapping its buffers and things like that because it actually waits. It's a polling kind of library that's been put together for it, so I have to look at that sometime later. But I did want to put some closure onto the electronic referee as far as the proof of concept to show you that it is working, and that it can detect a tennis ball. I was going to do this outside a little bit earlier today, but when I went out there I got pretty much attacked by mosquitoes. Up here in Canada, of course, the mosquitoes outside, they bite, and me with my English blood, I come up in big welts, and it hurts quite a bit. So I came back inside, and I've just managed to get set back up again so that I can record indoors instead. You people in the UK, you don't know how lucky you are where the mosquitoes don't bite you. Anyway, without further ado, I'm just going to retrain the camera on the displays and show you what's happening with it. I will go back to the code in a little bit once I've done the actual practical demonstration here on a small board that I've set up. I'm not on a full-size tennis court because I have some issues with the sensors in that they are creating a very wide beam, so that anything more than about a meter or so, they start interfering with the sensors that are adjacent to them. So I have them set about as far apart as I can, within reason, without having to take some silly steps of isolating the different beams. So anyway, let's go and reset the display, the camera onto the displays, and we'll go from there. So what I have here is a mock-up of the service line for the electronic referee. So the blue tape line you can see across the board here, that represents the actual service line, and the array of LEDs are set in alternating positions. So the side you're looking at right now, there are 2 transmitters and 3 receivers. The little module you can see at the end of the table is actually not connected to anything. It's actually just measuring the temperature and humidity, and every second it's transmitting it to the base station as well. I figured that I'll just throw that in for good measure. It's using a MSP 430G2553 microcontroller with a simple DHT11 temperature sensor on a CC11OL radio. So that's all there is, except for the battery, which is powering it, and it's been running on the same battery now for probably about a week, so it's actually doing pretty good. Anyway, the other things we've got, as I said, is the 5 sensors. The one at the far end, if that one that I'm just looking at right now gets triggered before any other sensors, then that's deemed as in. If any of these other 4 sensors will get triggered, then it's deemed as out in tennis, because it hasn't gone on the far side of the line, which the net, as far as we're concerned, is farther away from us than where the sensors are. So we're on the fault side of the service line. I've got 3 controllers down here. The one in the center, I'm just going to zoom in here so you can see. The one in the center here is the master, and it is, as you can see, receiving updates from the 2 transmitters. Now one of them is already detected the ball because I was messing around with it just before. So you can see there it's saying an F3 and the time down to the millisecond that the sensor was tripped. The other one is still in a W status, which when you start seeing the code, you will see that it is waiting for an event to occur, which in this case would be one of the sensors to trip. The bottom there where it says T equals 25, H equals 35, that's the output from the temperature humidity sensor. As I say, it's been running for about a week now. So up here it's 25 degrees with about a 35% relative humidity. And every 5 seconds it'll transmit its local time. Now that's not synced with any particular time clock. It's just converting the hours, milliseconds that it's been running for into a hours, minutes, and seconds duration. Of course, it's wrapped over a few times now because I'm only tracking up to hours on it, and I reset it. Oh no, actually, I think I reset it today, so it's been running for about 3 hours or so, and you see that just tripped through there, 3 hours 45 minutes. The other two sensors, which I'll just move to here, this is one of them. This has got the, as you can see there from that connector, it's got 3 transmitters on it, which only have the 2 wires, and it has 2 receivers, and they're both fault receivers. The position in the middle is actually the sense one. So this right here that I'm just putting my finger over, if that had a sensor in it, that would be deemed as the service line sensor. You've got your optocoupler in the middle, you've got your little FET. I put it onto a adapter board so that I could put it on the prototyping PCB. And then we have the display here. Let me just move the light a little bit so that you can see it better. There we go. So you can see this one, it still hasn't detected anything, and it's been running for about 10 minutes. If I actually go and put my hand in front of one of the sensors on that side of the board, let me just zoom out so that you can see me doing this. No tricks up my sleeve. So I'll go here and I'll just trip this. Have they gone off? Oh. I've set a 10-minute timeout on these things to turn the power off. So I've been sitting here talking for 10 minutes, I guess. Just going to hit a clear on this, and it should send a clear signal there. The count is just reset, and as you can see, the lights on the bottom of this board down here have just come back on. All the sensors are now lit up again. Of course, because I've reset it, everything says clear. So if I just zoom into this, you will see it now has everything clear on it. So let me just zoom back out again, and I'm going to just deliberately block one of the sensors. Okay, there we go. So that was a fault sensor, so it says it's now broken. Now if I go back to the middle one, all right, that broke at 22 seconds in after I had pressed the reset. Now if I look down on the display here, once it focuses in, the second board, because F2 is actually the 2 is the board that did the transmitting. F means it detected a fault, and it was 22 seconds 901 milliseconds in, and if I go back to this one, you'll see that corresponds 22,901 when it detected the break on its first fault line. Okay, now it's going to keep, now that it's got that, it's going to leave it at the bottom of the display until I clear it. The top one there, as you can see, it shows the fault as well. The other side is still waiting to detect something. So if I go over this side now and just come up here, if I just go block one of these sensors, let's pick the service line this time. All right, I've just blocked that one there. Now if I come back down here again, you'll see that on this one, the service line will be indicating is broken, the SVC, so it says they're broken. It was at 1 minute, 28 seconds, and 943 milliseconds since we hit the reset, and you can see there, it still remembered the fault, which was at 22 seconds, but the service detection has gone off as well, but I freeze the clocks when I detect an event, and you can see that it's there. So if a ball went through this and it actually tripped 2 sensors, you would know which one went first, and in this case it was a fault, so it will be out. I haven't put the code in there right this minute to detect which one comes first, and therefore put a big message up, because the Energia libraries, they're very limited in what you can do with the LCD display. And what I'm doing here is about all you can do. It can either display a bitmap across the whole screen, or you can put uppercase characters in it with numerics and a few like equals, plus, minus, and things like that. But that's really it. The Code Composer Studio libraries for these displays have got full graphics capability and everything. So once I've closed off the summer project, which is I'm just in the process of doing now, I'm going to go and try and learn a lot more about using the Code Composer Studio libraries and try and see if I can get them all working together, because I find that there's a lot of code there, but they won't work in combination with other things. So let me just reset this, and I will get a ball out and we'll see if we can detect it with a ball bouncing in one of the displays. So I've just cleared the display, and now what I'm going to do is zoom out a little bit so you can see. As you can see here, they're both waiting for an event to occur. I'm just going to zoom out on the board, and I'm going to try and bounce the ball. I've got myself a little tennis ball here, and I'm just going to bounce it as best I can right over the fault, the safe line. So right up about there, and that's it. So now the only thing that should have broken is the safe line. If I go back down to the display, this is the one that's monitoring that sensor. You can see the service line was broken, the fault lines are clear. The other side, the service lines there is clear because there's nothing connected to it, and the two fault lines are clear. And if I look at the main display, it's telling me that the service line was tripped at 35 seconds through. And the top display, as you can see there, the S3, which came from board number 3. Board number 1, by the way, is the master controller, just in case you're wondering. So board 3 sent the service alert at 35 seconds into the event. So if I just hit the clear button again, we just zoom back out a little bit. What I can do is send a command from here. I've got the button 2 at the bottom here hooked up, so that's good enough. So if I press this button here, it should clear things. So what it's just done is it's showed up one of the problems with the radios. Let me just turn this around just a little bit. Because the radios will sit in a loop, you tell it to wait for something to come in, and then you if nothing comes in after the timeout period, it'll go off and do the rest of the code that you have, and then it comes around again. So you can see here now they're 2 seconds apart. While I was holding the button pressed, I was continuously sending a clear command out on the radio at the broadcast channel, which is on identity 0. And they both received it, but one of them didn't catch the last one that went out. So it had already reset and is now running a couple of seconds ahead of the other board. If I try and do it again, see if I can get them to go together this time. See, in this case, only one of them has reset. Now the other one went a few seconds. Nope, that's not. That's rolled over to a minute. I try it again. Yeah, so the second one, W3, is now reset, but the first one is still going. I'm going to keep trying this. It will eventually catch both of them there. Now I've got them both in sync again. So you can see that's a bit of a pain, and it's not my code, at least I don't think it is. I've gone through it. I've spent a long time trying to figure out, without rewriting the libraries, what is causing this. And the only thing that I can conclude is that the radios are not, in the Energia library, they're not designed to really have multiple things talking to a master. They'll do point-to-point quite happily. And if you don't have a master doing a lot of other things, it will receive intermittently. And for instance, if I turn off these two slave boards, the ones on the left and the right, so this one and the one over there, if I turn those off and only leave the temperature transmitter going, it will sit there quite happily receiving for weeks and weeks and weeks without any issue, short of recharging the batteries. Without, I've had no issues with it. The minute I put all three boards on talking to the main center one, eventually it'll get to the position where they all try to talk at the same time, and it'll mess up the display. or something like that. The other issue with this is that they've got a lot of lines on the launch pads. As you can see, I've got 1, 2, 3, 4, 5 boards stacked on the 2 sensor boards. I've got 3 on the master board, and I've got 2 on, well, 2 if you include the battery on the temperature sensor board. Now that's all well and good, but first of all, the reason I don't have a battery on this board is because for some reason when I connect it, the whole board starts doing silly things. So I think it's the way it's connecting directly to the microcontroller. It's one of these ultra low power MSP 430F 5929s. So I've got to do some investigating as to why that occasionally will fail when I'm running it on the battery. The displays will occasionally also go funny as well. When you are driving these displays, they are ultra low power and they're really nice displays, but if you don't drive them just right, they can actually develop a charge on the voltage. You call it a bias on the crystals, which means it's like getting a shadow from what you've been having on the display, and it takes a while for it to go away. So you have to drive them properly, and there's not too many instructions available about doing that. I will be linking some in that will help other people using these things. The other thing I found is that the radio board is using the same pins as the LCD display. So I've tried to minimize the impact of that in code by just picking different pins and trying to turn off some of the functionality. Like I modified some of the LCD displays so that it avoids using the pins that are common, but it's not perfect yet. There are still some collisions occasionally when I'm trying to write to the display with the radios. So again, I think it may be to do with the drivers, but it's going to take some further examination. Anyway, let's get back to the electronic referee thing here, because I'm blathering on about other stuff and I'm sure you want to see this thing working. So it's sitting there now listening again. So what I'm going to do this time is I'm just going to bounce the ball randomly in the middle here, and we'll see what we get. And there we go. We got a fault on the first sensor board, and it was at 3 minutes and 28 seconds in, and as you can see, it's locked it onto the bottom display there. If I hit the reset button on this board here, hopefully I can clear that. Cleared one of them. So you can see here that F2 is not clearing at the moment, and I think what it is, I think the actual first board is locked up in the code there somewhere to do with the radio, because the radio is actually listening to everybody. So I've got 4 radios right here that are all talking to each other, and I think it might have locked it up. If I actually just hit the reset on the bottom of this board here without losing everything, it's right underneath here. Don't know if you can see that. I'm just going to hit the reset, put it back in, zoom out a little bit. So now it's clear, and as you can see, everything's now clear again. And they're both in the waiting state. So if I just randomly drop the ball on the, and I didn't even get it in the grid. Okay, and it's actually 2 of them picked up on the fault there, one on the left and one on the right, and both of them were on the fault line, so not the safe one. So if that was a tennis player, it would be out. Anyway, enough of the practical demonstration here. As I said, it's unfortunate I can't get it on a bigger playing area, but it's because the sensors won't keep the beams narrow enough. So I think this is enough from a proof of concept perspective that shows that it does work. There are, as I said, a few issues to resolve with the code, and I think that's going to take me reworking it into Code Composer Studio. So I have been trying to learn it, and half the battle is not actually knowing how to program in C. It's learning how the code and the microcontrollers work, because you're no longer in a wiring environment, which you are with Arduinos and Energia. You're now actually talking directly to the hardware, so it takes a lot more effort and time to actually figure that all out. I'm sure once I have, I will come back to this and redo it all in native code, and hopefully it's going to be a lot more reliable, much better displays and things like that. Anyway, I'll terminate this practical demonstration right now, and we're going to get back to the computer, and I'll put the code up so that you can see everything that's going on.